We have electrolysis of aqueous copper sulfate with inert electrodes, right? This is something we discussed. This is something जिसका आपको अंदाजा होना चाहिए because again inert electrodes हैं तो it must be made of graphite or platinum, right? This is something I want you to know. I don't think I mentioned this before, but platinum can also be used as an inert electrode, right? Platinum can also be used as an inert electrode. ठीक है? Okay, so let's talk about aqueous copper sulfate solution जो कि हमने we did discuss that in the previous class. Right, whenever we say aqueous and we don't mention whether it's concentrated or dilute, we will assume that's dilute, right? And in this case we have two anines, the hydroxide anine and the sulfate anine. As I told you, the golden rule says that sulfate anine and nitrate anine can never ever be deposited. ठीक है, so it doesn't really matter ये dilute solution है या concentrated है, sulfate है तो that is never going to be deposited. The hydroxide ion is the one that is going to get deposited to the anode. ठीक है, and there we have this equation, we derived it earlier. We have the cathode key equation, we have a pink solid copper being formed. We did discuss its observations. Iski observations ye hain ki blue color of the electrolyte becomes colorless. And why is that? Because the blue color, the light blue color, is because of the Cu2 plus ion. This is because of the copper cation. And since this copper cation goes towards the cathode, this gets removed from the electrolyte में से ये निकल जाता है, तो electrolyte में से blue color भी निकल जाता है और electrolyte becomes colorless. Why colorless? Because अगर ये निकल गया तो फिर पीछे we are essentially left with water and sulfate ions, right? And water is colorless. You see, water is colorless, so hence blue से colorless इसका color हो जाता है. That's the first observation. The second observation is that pink copper is deposited at the cathode. Why cathode? Because cathode is where the cation goes. The cation is copper 2 plus, and copper 2 plus C, it goes towards the cathode. It gains the electrons that's coming, ये वाले electrons, the electrons that are coming all the way from the anode to the cathode, traveling through the external circuit, वो इन्हीं electrons को gain करता है, and hence it forms a pink solid. And since it forms a pink solid, so that pink solid gets attached like this, इस तरह से, right? Towards it gets attached on the cathode. ठीक है, and hence the size of the cathode increases. Why is that? Because the pink solid gets attached to the cathode, right? अच्छा, अब तक हम जो examples करते आए थे, we were using inert electrodes, right? Either graphite or platinum. But we'll do this exact example, but we'll use reactive electrodes in this case, right? We'll use reactive electrodes in this case, right? And here I want to introduce you to a new concept. This is the final major topic of this chapter. After this we have hydrogen oxygen fuel cell, although that was removed from your syllabus, but that has been added again for the 2026 syllabus, so we'll cover that, although it won't take much long. It's a maximum 10 से 15 मिनट का concept. ठीक है, okay, so application of electrolysis includes two things. One is copper purification and the other is electroplating. Both follow the exact same phenomena. Both have reactive electrodes instead of the inert ones, as in the graphite or platinum ones, and that is something which I want you to learn now. Okay, let's talk about copper purification. Let's talk about copper purification. And how does copper gets purified? Let us talk about that. Okay, so copper purification, what exactly happens is, okay, so copper purification में जो होता है, we do electrolysis, right? We do electrolysis of aqueous copper sulfate using copper electrodes, right? Now copper is a reactive metal. It's a metal that can react, that does react in fact, right? So using copper electrodes, and these are the reactive electrodes, and here fundamentally कहानी पूरी की पूरी बदल जाती है, because we are no longer using graphite या platinum के inert electrodes, right? That is how it is. अच्छा जी. So let's draw our electrolytic cell. Right, let's draw our electrolytic cell. Let's draw our electrodes there, right? Again, as I mentioned, this is something you should be able to draw. You can very well be asked on the exam to draw the electrolytic cell, label it, and do all of it yourself. जरूरी नहीं कि आपको बना बनाया मिले and you're just asked to label it. That is now how it works. ठीक है, there you have your electrolyte and the electrodes are half dipped in it. ठीक है. अच्छा, अब scene here, because this is the one that's connected to the positive terminal of the battery, this is the one that is going to attract the anion, and therefore this is the anode and this is the cathode. ठीक है. This is the cathode and this is the anode, right? That's how it is. अच्छा जी. Okay, so what I want you to realize is why would we need to purify copper? You see, when we extract elements, when we extract metals from the surface of the earth, आपने सुना होगा कि जो भी metal हम, like these metals are naturally occurring और ये हम earth की surface से निकालते हैं, right? So whenever we extract these metals from the surface of the earth, so what we usually get is, for example, we extract this huge piece of a metal, right? This is not going to be a pure metal. This is not going to be copper, or this is not going to be gold, right? Or this is not going to be silver. ठीक है. This in turn is going to be something that's combined. ठीक है. मतलब इसमें copper भी होगा, ठीक है, इसमें gold भी होगा, इसमें silver भी होगा, right? और ये सारा एक contaminated sort of form में होगा. You know, this is not something that exists on its own. तो अब हमें क्या चाहिए? We need the copper. We need to purify copper, right? And impurities क्या होंगी? Impurities होंगी, I'm sorry about that. The impurities will be silver and gold in this case, right? So these are our impurities. ठीक है. हमें इनको remove करना है, right? And we only want copper. ठीक है. और you see, because these elements occur together और ये they are extracted together, we want copper अलग से, and the process of, you know, getting this copper अलग से, purifying this copper, you see, purifying means removing impurities, और वो impurities होंगी elements like silver, gold, or any element that copper comes with, ठीक है, or it gets extracted with. अच्छा जी. So what do we do? अच्छा, यहाँ पे there are certain things I want you to take note of. अच्छा जी. What are those things? अच्छा, what we do is that the anode is made up of, right? The anode is made up of impure copper, right? Impure copper. What do I mean by impure copper? The impure copper is the one extracted from the earth. जिस form में वो earth से extract होगी, like you see this form, और इसके अंदर again we'll have some gold and we'll have some silver and we'll have some copper as well. We'll have some gold, we'll have some silver, और हमारे पास उसमें copper होगी और हमें उसमें से copper चाहिए, right? So this is the impure copper, right? This is the impure copper. Let me mark it there as well. This is impure copper, right? And what happens is the cathode, the negative terminal is made up of pure copper. ठीक है. अब इस केस में there is no graphite, there is no platinum. ठीक है. This rod is basically pure copper की ही ये rod है, right? Impure copper की rod है. This rod in particular, you see, the anode is as it is extracted from the earth. हमने earth से extract किया, like you see, this is something we extracted from the earth. इसके अंदर gold, silver, copper, and you know this has multiple elements apart from copper. हमने ये as it is यहाँ के anode पे लगा दिया, ठीक है. So what happens is कि this cathode right here is made up of pure copper. ठीक है, this is pure copper. अच्छा जी. What we do is, another golden rule is KKK. The electrolyte is a salt solution of copper, right? The electrolyte is also the salt solution of copper, right? And why is that? That is something that we're going to discuss. And see, that is the one we're using, copper sulfate solution. We have aqueous copper sulfate solution, right? And we have aqueous copper sulfate solution. This is the diagram. अच्छा जी, अब होता क्या है, right? अच्छा, so let's identify the ions जो कि इसमें होंगे. Because it's aqueous, it's gonna have H plus, it's gonna have OH minus, it's gonna have copper 2 plus ion from this part right here, and it's gonna have sulfate ions, right? अच्छा, अब again जैसे हमने inert electrodes के केस में बात की थी कि sulfate is never gonna go, hydroxide is the ion that's gonna go towards the anode, right? But what happens is that only used to happen in the case जहाँ पे जो electrodes हैं हमारे electrodes हैं वो inert थे, right? उस केस में the anion would go to the anode, the cation would go to the cathode, and boom, oxidation and reduction happens there. ठीक है? But इस केस में whenever we have reactive electrodes, जब भी हमारे पास जो एनोड है अगर ये रिएक्टिव है तो anion यहाँ नहीं आएगा, this itself will undergo oxidation, right? As we know anox, right? Oxidation occurs at the anode, right? अब whenever, I'm going to repeat this, whenever we used to have inert electrodes, तो ये जो ऑक्सीडेशन एनोड पे होती थी, जो इस एनोड पे ऑक्सीडेशन होती थी वो A9 की होती थी, राइट? वो इस A9 की होती थी, राइट? बट व्हेन दिस इलेक्ट्रोड इज रिएक्टिव, व्हेन दिस एनोड इज रिएक्टिव, तो जो ऑक्सीडेशन होगी वो इसका अपना मेटल करेगा, राइट? ये A9 नहीं जाएगा, दिस A9 वोंट गो, सल्फेट ने तो वैसे भी नहीं जाना था, सो दैट इज नॉट गोना हैपन. इसके अंदर जो मेटल है that is gonna undergo oxidation itself. What do I mean by that? अच्छा जी, let's talk about that. एक छोटा सा another concept I want you to realize so that you understand कि why essentially copper undergoes oxidation and not silver and gold, right? Because this one has copper, this one has gold and silver, ठीक है? इसमें ये तीनों elements हैं और how do we know कि copper is the one that's gonna undergo oxidation? Why not gold? Why not silver? That is because gold and silver are very less reactive as compared to copper. Not very less reactive, but they are less reactive. You see, अगर मैं आपको reactivity series दिखाऊं, if I show you the reactivity series, see, copper के नीचे silver है और उसके नीचे gold है, right? तो silver and gold are less reactive than copper. Since they are less reactive than copper, they like to stay in their neutral states. As we discussed earlier, जो भी चीज़ कम रिएक्टिव होगी वो अपनी न्यूट्रल स्टेट में रहना पसंद करेगी और जो ज़्यादा रिएक्टिव होगी दैट वुड प्रेफर कि ओके मैं आयोनिक स्टेट में रहता हूँ. Why is that the case? Because in order for like an ionic bond to form, and the formation of ionic bond is like a reaction, right? तो रिएक्शन होने के लिए उसे आयंस में कन्वर्ट होना जरूरी है, राइट? Na का पॉजिटिव आयन होगा तो वो Cl के नेगेटिव आयन से कंबाइन करेगा, राइट? Na in its atomic form can never combine with chlorine in its atomic or molecular form, right? It has to form ions. So again, that is the logic basically, because copper is more reactive and gold and silver are comparatively less reactive. So what happens is that copper undergoes oxidation and copper basically forms an ion, right? So what happens is let me write equations for anode and cathode respectively. चलें anode पे बात करते हैं. What happens at the anode? Usually see, अगर हम inert electrodes use करते हैं तो anode पे क्या होता है कि hydroxide ion anode पे चला जाता. Simply that would have been the case. Sulfate is never going to go to hydroxide ion anode पे जाता, and it must have formed oxygen and the water, और वो जो हमने equation derive की थी the other day. But since the anode is reactive, it's made up of copper, it's made up of gold, it's made up of silver, right? Actually this is silver and this is gold. So see, what happens is since it's made of copper, and copper is the one जो कि is going to undergo oxidation as we discussed. So what's going to happen is this is copper, and after oxidation this is copper. See, again step 2, let's balance the number of particles. They are balanced. Let's balance the number of electrons. It's going to lose 2 electrons to form this. So here you have it, right? Here you have it. This why 2? Because it has a 2 positive charge and 1 electron has a 1 negative charge. So in order to balance this positive 2, we have a negative 2, and here the charges are balanced on either side of the equation, and that's what happens. Okay, that is what happens. Achha, let's talk about the cathode. For a moment. Anode पे तो ये होगा, right? Let's talk about the cathode. अच्छा जी. Now the cathode पे कहानी is pretty similar to what we have discussed earlier. अब होता ये है, होगा ये, right? Let's talk about, अच्छा. Now this is impure copper. What happens is it releases copper 2 plus ions into the electrolyte, right? It releases copper 2 plus ions into the electrolyte, right? ये भी copper 2 plus, और copper 2 plus ions were already there as well. You see, this copper 2 plus was from copper sulfate. You see, उसके already भी copper ions थे, and this releases more copper ions into it, right? Because it undergoes oxidation. ये वाला जो copper था, you see, this copper is the one at the anode right here, the same copper, ठीक है, and it converts into Cu2 plus, which is released into the electrolyte. What happens to these electrons? These electrons stay here and they travel from the external circuit, as we discussed earlier कि electrons travel from the external circuit to the cathode. अब होगा क्या? What happens at the cathode? See, Okay, now the option is again यहाँ पे वही पुराने वाला कॉन्सेप्ट लगेगा. We have Cu2+ and we have H+. इसमें से कौन सा जाएगा यहाँ पर? The one that is below in the reactivity series, and that is pretty evident. Copper is below in the reactivity series. So Cu2+ is going to go towards the cathode. और cathode पे reduction होती है. Reduction means loss of electrons. So loss of electrons के बाद this 2 positive charge converts into a neutral copper, right? This is how it is. And let's balance the number of particles that are already balanced. Let's balance the number of charges. How many electrons does it need? It needs 2 electrons, and this is what's happening. This is what's happening at the cathode. See, अब कहानी क्या हो रही? Let's understand that. Let's understand the story right here. You see, this is the anode made up of impure copper. इसके अंदर copper है, silver है, gold है, and it can have other metals in an impure form combined with copper. ठीक है? What happens is copper loses its electrons and becomes a copper cation, and the copper cation is released into the electrolyte, right? जहाँ already copper cation है, but it releases more of it, right? These two electrons travel all the way from the positive to the negative electrode throughout the external circuit. As we established earlier, electrons ने हमेशा external circuit से जाना है. E for electrons and E for external circuit. ठीक है? And the electrons travel through the external circuit towards the negative electrode. और फिर यही electrons जो यहाँ आएंगे, right? We see यहाँ वो electrons आए होंगे, and copper 2+ ions will go towards the negative electrode, because again it is below in the reactivity series as compared to hydrogen, right? It goes there, it sees okay वो electrons आए हुए हैं जो कि इसी copper ने पीछे lose किए थे, and this copper again gains this electron. So essentially what's happening is कि इस copper ने electrons lose किए and turned into this. And फिर वही electrons जो इसने lose किए वो यहाँ आ गए, and this goes here again to gain the same number of electrons. You see this equation and this equation is the polar opposite of each other. यहाँ पे the copper is losing its electrons, and then यही the copper ion is gaining the same electrons to form the same copper again. You see, this is the exact polar opposites. But what's the difference here? Difference यहाँ पे ये है कि यहाँ पे जो copper थी, that was on the impure side of things. अब यही copper move करके यहाँ आ गई है, right? You see, यहाँ पहले ही pure copper थी, and we got more pure copper over it. ठीक है? We got more pure copper over it, right? यहाँ पे same copper, this same copper moved from here to here, but it moved from here ताकि we get the pure copper all on one side. ऑलरेडी प्योर कॉपर पे जब हम और प्योर कॉपर लगाएंगे तो सारी की सारी प्योर कॉपर हमारी नेगेटिव इलेक्ट्रोड पे आ जाएगी, और जो पॉजिटिव इलेक्ट्रोड है विच इज आर एनोड, यहाँ पे सिर्फ इम्प्योरिटीज रह जाएंगी, राइट? सो दैट इज हाउ वी बेसिकली यू सी प्योरीफाई कॉपर, राइट? दैट इज हाउ वी प्योरीफाई कॉपर. सो दैट इज समथिंग यू नीड टू अंडरस्टैंड. ठीक है? दैट इज समथिंग यू नीड टू अंडरस्टैंड कि यहाँ पर क्या हो रहा है, यहाँ पर ये हो रहा है, राइट? सो या दैट्स how it is. अब अगर मैं आपको कहूँ कि इसकी मुझे आप you see net equation लिख दो, right? Let me just adjust this for a moment, and इसके बाद we'll write its net equation. The net equation rules stay the same. You see, if I say k, write a net equation for me. So combine the reactants. Let's combine the reactants. These are the ones जो कि हम combine करेंगे. Okay. So we have copper plus Cu2 plus 2 electrons, and then again we have the same things on the on the product side of things. That is copper plus Cu2 plus 2 electrons, right? And what happens is these electrons get cancelled, and then the final equation turns out to be, let me write it in a better way. The final equation turns out to be this. Right? This is what happens. And see, you can write the oxidation state here. Ye solid hai. This is aqueous, and ion is always in, like, see, the metal is always in solid form in its ground state. So what's actually happening is कि ये वाला ion जो है, this is getting converted into this, you see, and this solid is getting converted into this. So this is the net equation, right? हो यही रहा है, हो essentially यही रहा है. अच्छा जी. Now if I wanted you to visualize this better, and make sense of whatever I said here, I am gonna give you a picture that I have saved. ठीक है, अच्छा जी. Now essentially what is happening? अब essentially यहाँ क्या हो रहा है? Let's discuss. अच्छा जी. So what's happening is, अच्छा, as we discussed earlier, the impure copper anode, right? इसमें we have copper, we have silver, and we have gold, right? What happens is कि copper loses its electrons, turns into the ion. This ion is going to go towards the cathode because see, the cathode always gains the cation and electrons will flow from the external circuit to here, और फिर यही वाला copper is going to gain the same electrons to form copper again. But this time this copper is getting formed on the cathode and not on the anode. So essentially copper उठ के anode से cathode पे आ रहा है, right? You can see here as well कि होता ये कि copper उठ के anode से cathode पे आ रहा है. Why? Because you see इधर copper cathode का size बहुत thin है and इधर it's become way thicker. Right, that shows कि कुछ ना कुछ ऐसी चीज है जो कि एनोड से उठ के कैथोड पे आई, and that is copper. ठीक है, and what's happening is this part here we refer to it as let me write it like this. We refer to it as the anodic sludge. What is the anodic sludge? This is जो impurities थी, this is the gold and the silver, right? The gold and the silver falls off and deposits at the bottom. अब ऐसा क्यों नहीं होता कि gold और silver ions बन के you see इस electrolyte का part बन जाए? That's not how it works. Why is that? Because gold and silver are unreactive in this case and they would prefer staying in their natural state, right? तो वो यहाँ पे नीचे deposit हो जाते हैं, settle down at the bottom. They settle down at the bottom. So see, this is the purification of copper. Let's talk about the observations. Right, observations की बात करते हैं. Let's compare these observations to the one we discussed earlier in the case of copper sulfate, जो कि जिस पे हमने establish किया था in the case of inert electrodes कि the light blue color fades, pink copper is deposited at the cathode size increases, right? तो हम यहाँ पे कुछ similarities और differences उस observation से इसके compare करेंगे, ठीक है? So that is what we're gonna do. Here you have it. अच्छा जी. So the observation is, first observation is the color of the electrolyte remains unchanged. अब ये क्या बात हुई, राइट? हम पहले तो कहते थे क्योंकि Cu2+ अगर जा ही रहा है तो इसमें भी इसको ब्लू से कलरलेस हो जाना चाहिए, राइट? बिकॉज वी सी जा तो Cu2+ ही रहा है, राइट? दिस Cu2+ इज गोइंग देयर, बट द थिंग इज जो Cu2+ यहाँ से जिस रेट पे आ रहा है उसी रेट पे यहाँ जा रहा है, राइट? सी जितना Cu2+ यहाँ से आएगा उतना ही यहाँ जाएगा, राइट? सो द कलर इज गोना रिमेन द सेम बिकॉज सी दिस कॉपर सल्फेट, ये वाला Cu2+ भी तो था, राइट? सो जिस रेट पे ये आ रहा है उसी रेट पे ये डिपॉजिट होगा. सो जो ऑलरेडी Cu2+ वहाँ था दैट इज गोना रिमेन देयर और इसका कलर चेंज नहीं होगा. आई रिपीट, इसका कलर इसलिए चेंज नहीं होगा बिकॉज जिस रेट पे कॉपर 2+ आयंस पॉजिटिव इलेक्ट्रोड से आ रहे हैं उसी रेट पे नेगेटिव इलेक्ट्रोड यानी कैथोड पर जाएंगे, राइट? और जो ऑलरेडी प्री एग्जिस्टिंग कॉपर 2+ आयंस थे बिकॉज दे स्टे देयर, तो इसके कलर में कोई चेंज नहीं होता, राइट? एंड दिस इज वन डिफरेंस बिकॉज वहाँ पे व्हेन वी यूज्ड इनर्ट इलेक्ट्रोड्स हमने एस्टैब्लिश किया कि जो कॉपर 2+ आयंस है बिकॉज ऑल ऑफ देम दे गो टू द नेगेटिव इलेक्ट्रोड, तो सेंस उसका लाइट ब्लू कलर भी साथ फेड हो जाएगा, बट दैट इज नॉट द केस हियर, ठीक है? दैट इज आवर फर्स्ट ऑब्जर्वेशन, right? And this is because you can be asked this is because the rate of, you see, the rate of what do we call it, the rate of you see, the rate of oxidation at anode, you see, is equal to rate of deposition, right? The deposition at the cathode. What this essentially means is this is the process of oxidation, right? ये oxidation हो रही है because it left electrons here और ये positive ion बन के electrolyte में आ गया, and this is deposition. This is it being deposited, right? So जिस रेट पे यहाँ आ रहा है उसी रेट पे आगे जा रहा है. This Cu2+, the copper 2+ ions that are given by copper sulfate solution, they remain fairly the same there, और वो electrolyte के पार्ट ही रहते हैं, तो electrolyte remains blue. This remains blue और इसके कलर में कोई चेंज नहीं आता. That is one of the observations. The second of the observation that you can clearly see is कि cathode का size increase हो रहा है, right? इधर it's very thin, इधर it's very thick, and this is something that is the same. If you go up and you see, this is something that is similar to what was happening here, right? This is something that was similar to what was happening here because the size of the cathode would increase here as well. क्योंकि यहाँ भी essentially यही होता था, copper used to get deposit to the cathode, यहाँ पे pink color का solid आ जाता था और इसका size भी बढ़ता था. You know, see, this is something that's common, but due to different reasons, it's happening due to a different reason than it did in the case where we had inert electrodes. ठीक है? So we say कि the size of anode increases. ठीक है? The size of anode, no, actually no, it's the cathode size that increases. I am very sorry, it's the size of the cathode that decreases. क्योंकि वहाँ ही cation जाएगा. I'm very sorry. The size of cathode increases. ठीक है? Pink copper gets deposited there. ठीक है? Pink copper gets deposited. You see, I would recommend you to avoid your pink copper वाली बात in this case because you see the pure copper cathode is already made of pure copper in its solid form, and solid form में ये already pink होगा. तो जो उसके ऊपर कॉपर लगेगी वो भी पिंक ही होगी. तो लाइक यू नो सी पिंक वाली आई डोंट थिंक सो. यू कैन जस्ट मेंशन इट टू एक्सप्लेन फर्दर कि ओके इसका साइज इंक्रीज हो रहा है और वो साइज पिंक कलर में ही इंक्रीज हो रहा है, राइट? ऐसा नहीं कि इसके यहाँ ब्लू कलर लग रहा है या ब्लैक लग रहा है, समथिंग पिंक कलर में ही ये साइज इंक्रीज हो रहा है, राइट? सो दैट इज समथिंग यू कैन इलैबोरेट फर्दर. अच्छा जी, व्हाट एल्स डू यू थिंक? आपको और क्या दिख रहा है? लाइक लेट्स टॉक अबाउट द साइज ऑफ द एनोड. Let's talk about the size of the anode because you see the size of the anode decreases. इसका size decrease हो रहा है because of two reasons. एक, the Cu2 plus ions go into the electrolyte and from the electrolyte it goes to the cathode. और दूसरा ये कि the impurities they fall off and they fall off as anodic sludge and settle at the bottom of the container. Settle at the bottom of the container, right? So what we say is size of anode decreases. ठीक है? And if anyone asks you, you can just say that this is because it's dissolving and because it's losing copper 2 plus ions and they are traveling towards the, you see, towards the negative electrode, and that is how you are gonna talk about it. ठीक है? This is what's happening. Again, I am going to repeat this one. Since we are using copper electrodes and copper electrodes are reactive, whenever reactive electrodes are used, एनोड पे वो कहानी नहीं होगी कि A9 जाएगा और वहाँ जाके यू सी इट विल अंडरगो ऑक्सीडेशन एंड यू नो लॉस ऑफ इलेक्ट्रॉन एंड स्टफ. नो, अगर तो एनोड इज ऑलरेडी रिएक्टिव तो जो ऑक्सीडेशन होगी वो उसी मेटल की होगी जिससे वो एनोड बना, राइट? एंड इन दिस केस कॉपर, बिकॉज द अदर इम्प्योरिटीज जो कि कॉपर के साथ हैं दे आर बिलो कॉपर इन द रिएक्टिविटी सीरीज. तो कॉपर विल टेंड टू फॉर्म आयंस एंड इट विल यू नो फॉर्म आयंस, राइट? अब अगेन दिस इज समथिंग जो कि इज वेरी basic, but it is that you should be able to know it all stems from the idea of reactivity series at the end of the day. Acha ji, let's talk about the second application of electrolysis, which is electroplating. ठीक है? Electroplating. Let's talk about electroplating. And electroplating is very, very similar to what we just discussed. Iski logic is exactly the same. Its logic is exactly the same. Let's talk about it. अच्छा जी, तो electroplating में क्या होता है? Electroplating has the same phenomena. It has the exact same phenomena. What we do is see, let's talk about electroplating. A metal ring with gold. Right? We can have a very ordinary looking metallic ring, लेकिन इसको हम गोल्ड से करते हैं, जिसके बाद हम कहेंगे क्योंकि इट्स अ गोल्ड रिंग, राइट? इसके ऊपर हम गोल्ड डिपॉजिट करते हैं. हाउ डू वी डू दैट? इट अंडरगोज द सेम फिनोमेना एज वी जस्ट डिस्कस्ड, बट लेट्स डिस्कस दिस वन इन डिटेल एज वेल. अच्छा, बिफोर आई डू दैट लेट मी टेल यू वन थिंग कि व्हाट इज द रीजन we use copper sulfate solution, right? अच्छा, यहाँ पे we have impure copper, यहाँ पे we have pure copper. ज़रूरी क्यों है कि हम यहाँ copper का salt ही यूज़ करें? हम यहाँ पर zinc का salt या किसी और metal का salt क्यों नहीं यूज़ करते? Okay, the first reason is अगर यहाँ पे हम for example gold का salt यूज़ करते, right? अगर हम इसकी जगह अगर हम gold का salt यूज़ करते, तो what would have happened is कि since gold is below copper in the reactivity series, फिर होता ये कि यहाँ पर होता गोल्ड, यहाँ पे होते गोल्ड के आयंस, राइट? आई थिंक इट हैज़ +3 चार्ज. अच्छा, AU इट इज़. अच्छा ठीक है, गोल्ड के आयंस होते हैं और फिर क्योंकि दैट वुड हैव बीन लोअर देन कॉपर इन द रिएक्टिविटी सीरीज, तो दे मस्ट गेट डिपॉजिटेड और फिर ये डिपॉजिट होते हैं. और फिर जो हमारा गोल था कि हमें प्योर कॉपर ऑन वन साइड चाहिए, प्योर कॉपर ऑन वन साइड चाहिए, वो ना होती, हमें प्योर कॉपर के साथ दोबारा गोल्ड की कंटेमिनेशन मिलती है. एंड दैट समथिंग वी डिड नॉट वांट, दैट इज समथिंग दैट वी डिड नॉट वांट. ठीक है, दैट इज द रीज़न वी डोंट यूज़ कोई और मेटल का सॉल्ट, स्पेशली दोज बिलो. एंड यू कैन से कि अच्छा कॉपर से ऊपर वाले अगर मेटल्स हैं, राइट, वी सी द रिएक्टिविटी सीरीज, कॉपर से ऊपर वी हैव अ लॉट ऑफ अदर मेटल्स. कॉपर से ऊपर जी हमारे पास टिन है, आयरन है, जिंक है, कार्बन है, एल्यूमिनियम है, मैग्नीशियम, कैल्शियम, सोडियम, पोटेशियम, ऑल दीज मेटल्स आर अबव कॉपर. सो व्हाई कांट वी यूज देम? बिकॉज अगर हम उनको यूज़ करें तो सी, अगर हम फॉर एग्जांपल सोडियम का यूज़ करें, राइट, अगर यहाँ सोडियम होता भी, अगर यहाँ इसकी जगह सोडियम होता भी, स्टिल कॉपर वुड हैव गॉट डिपॉजिटेड बिकॉज कॉपर इज बिलो रिएक्टिविटी सीरीज, राइट. कॉपर रिएक्टिविटी सीरीज में नीचे है तो इट वुड हैव डिपॉजिटेड. तो हम क्यों कोई ऐसा सॉल्ट नहीं यूज करते ऑफ अ मेटल दैट एग्जिस्ट्स अबव कॉपर इन द रिएक्टिविटी सीरीज ऑफ मेटल्स? The reason for that is that although we do say that the one that is below in the reactivity series will get deposited and the one that is above will not get deposited, but in reality थोड़ा सा वो आयन भी डिपॉजिट होता है जो कि रिएक्टिविटी सीरीज में ऊपर है. लाइक अगर फॉर एग्जांपल यू सी 98% ऑफ द आयंस गेट डिपॉजिटेड ऑफ कॉपर, तो ऐसा है कि 2% ऑफ द आयंस सोडियम के भी डिपॉजिट होंगे. लाइक इन थीरी तो यही होता है कि कॉपर जाता है, राइट, बट इन रियलिटी थोड़ी सी कंटेमिनेशन हो जाती है. तो इन ऑर्डर टू बी 100% सेफ कि कॉपर ही आए और कॉपर ही यहाँ जाए, तो हम कॉपर का ही सॉल्ट यूज कर लेते हैं, राइट, ताकि कोई और किस्म का आयन यहाँ अवेलेबल ही ना हो, राइट. दिस इज समथिंग आई वांटेड यू टू नो. अच्छा जी, एंड दैट इज द एग्जैक्ट रीजन व्हाई वी विल डू थिंग्स द वे वी डू इन इलेक्ट्रोप्लेटिंग. ठीक है, लेट्स ड्रॉ दिस हेयर. ठीक है, we have our positive electrode also known as the anode, the negative electrode also known as the cathode. ठीक है, and here you have positive charges, ठीक है, and there you have negative charges. ठीक है, and we draw a container again. I want you all to be comfortable with drawing the electrolytic cell of any sort of electrolysis that I ask you to do so. ठीक है, and here you have it. अच्छा जी. Now what happens is see, अच्छा तो अब यहाँ हम क्या करेंगे? यहाँ हम ये करते हैं, in case of electroplating, what we do is कि हम एनोड पे वो चीज़ लेते हैं जिसको हम इलेक्ट्रोप्लेट करना चाहते हैं, राइट. ओके, सो what is electroplating at its core? Like you see, just as I told you, we have a ring and this is a normal metal से बनी हुई ring and we want to make it a gold ring, right. हम चाहते हैं कि इसके ऊपर गोल्ड की कोटिंग हो जाए, गोल्ड इसको इलेक्ट्रोप्लेट करे, राइट. सो हम इसको गोल्ड की कोटिंग करते हैं एंड दैट इज द प्रोसेस ऑफ इलेक्ट्रोप्लेटिंग थ्रू द यूज ऑफ इलेक्ट्रिसिटी, थ्रू द यूज ऑफ दिस प्रोसेस ऑफ इलेक्ट्रोलाइसिस. अच्छा जी, तो हम एनोड पे वो ऑब्जेक्ट लेंगे, let me write it clearly. Anode has the object, in this case let's talk about a ring, the ring to be electroplated, right, to be electroplated. और रिंग को हमने इलेक्ट्रोप्लेट करना है गोल्ड से, सिंस गोल्ड इज द मटेरियल जिससे हम इसको इलेक्ट्रोप्लेट करना चाहते हैं. सो द कैथोड Oh, okay. I just realized. I mixed it up. ठीक है. The cathode is actually the object to be electroplated, right? And the anode is the material with which we want to electroplate the object, right, the object. अच्छा, you see इसकी और examples can be कि you see spoon getting electroplated with silver, right, because all the spoons are mostly silver. तो silver उसके ऊपर हम इलेक्ट्रोप्लेट करते हैं. और यू कैन से यू मस्ट हैव कम अक्रॉस द कॉन्सेप्ट ऑफ जो गोल्डन आईफोन्स है, राइट. यू सी दे से दैट दे आर मेड ऑफ गोल्ड, राइट. दे आर गोल्ड प्लेटेड आईफोन्स. और उसमें होता ये कि द आईफोन इज इलेक्ट्रोप्लेटेड विद गोल्ड, राइट. दैट इज हाउ इट इज. अच्छा जी. नाउ एज आई से कि कैथोड, the cathode has the object which is the ring in this case to be electroplated. So let's replace the cathode with a ring, right. This is the cathode, and this is, I'm sorry about that, this is the cathode and this is a ring, right. This is a ring. Okay, you see this is the ring. Acha, and the anode is the material with which we want to electroplate the object. This anode is going to be made of gold in this case because we want a gold ring, ring. ठीक है. तो what happens is कि this anode is made up of gold. ये gold का anode है, and this is the ring that is the cathode. ठीक है. अब होगा ये, again we'll use the salt of the material with which we want to electroplate the object, right. So what I'm gonna say is कि the electrolyte is going to be the salt. ठीक है, जो कि इस ही केटाइन से बना होगा, राइट. गोल्ड के ही केटाइन से बना होगा, राइट. सो लेट्स यूज इलेक्ट्रोलाइट AuCl3, राइट. लेट्स यूज AuCl3. आई थिंक AU के ऊपर चार्ज 3 ही होता है. लेट मी जस्ट कंफर्म चार्ज ऑफ गोल्ड. आई थिंक इट इज +3. आई एम प्रीटी श्योर. Yeah, it does exist as +3. So yes, electrolyte will be gold chloride, right. I don't know what the chemical name of this is, but AuCl3, let's talk about it. Let's assume it is aqueous AuCl3. ठीक है. अब what happens is again, is this anode inert or is this anode reactive? It's reactive, right. So since it's reactive, okay, first पहले इसके ions लिख लें. We have H plus ions, we have OH minus ions, we have Ag3 plus ions, and we have Cl minus ions. अच्छा जी. And since this is reactive, तो it ऐसा नहीं होगा कि OH minus goes there, right. That is not gonna happen. What's gonna happen is कि the oxidation is gonna happen of the metal that this anode is made up of. And what is that metal? That metal is gold, right. So what happens on the anode is, let's write the equation of the anode. Anode की equation लिखते हैं, and इसमें होता है कि like we have gold in its starting form and it turns into this ion, ठीक है, and it loses like 3 electrons to do so, ठीक है. And see what happens is कि this is solid gold, and it converts into Ag3 plus ions, right. Ag3 plus ions, much like जो कॉपर की प्योरिफिकेशन में हमने पढ़ा था, उसी तरह से this material undergoes oxidation itself. You see OH minus अगर इधर लिखें, and if I say कि what happens is कि there we have Ag3 plus, right. That is what's happening. Again, what's going to happen is that the rate of this oxidation is going to be the rate of deposition, right. This gold is going to go there, and again the 3 electrons that it lost, वही electrons external circuit से travel करते वापस इधर आएंगे, इस ring पे आएंगे, and this cation is going to go there as well. The electrons will come there as well, and this is going to gain the same electrons, just like copper, just like purification of copper वाला case. We have cathode. What we're going to say is कि cathode पे आ गए हैं electrons. We have the gold cation, we have the 3 electrons, and this converts into gold. And as you see, this is again the reverse process of this. The only difference is that the gold has moved from here to here. And as such, जो ring पे gold, the ring is plated with gold. The ring is gold plated now, and thus we can call this a gold ring now. We can call this a ring made of gold rather than a normal metallic ring. And that is exactly what's happening. This is following the same principle as copper purification. What happens is the oxidation happens of the material that the anode is made up of. In this case, that's gold. Oxidation happens, it turns into gold cations. The gold cations move towards the cathode. The electrons that it has lost travel all the way through the external circuit and goes towards the cathode, it gains the same electrons that it lost earlier here. The only reason is कि ये Ag पहले anode पे था और अब ये उठ के cathode पे produce हो गया. That is the only difference. And the same goes for copper purification, correct? Why do we use a copper का salt in case of copper purification and gold का salt in this case? Why do we use the electrolyte? Electrolyte के अंदर हम वही उसी मटेरियल का सॉल्ट क्यों यूज़ करते हैं जिससे पॉजिटिव इलेक्ट्रोड बना हुआ है? बिकॉज वी डोंट वांट किसी भी और किस्म का आयन टू गेट डिपॉजिटेड एट द नेगेटिव इलेक्ट्रोड, राइट? अगर हम यहाँ पे सोडियम प्लस यूज़ करते तो सोडियम वुड हैव इलेक्ट्रोप्लेटेड दिस रिंग एंड वी डोंट वांट सोडियम की रिंग, राइट? वी डोंट वांट सोडियम की रिंग, वी वांट गोल्ड की रिंग. दैट इज़ व्हाट सेल्स, राइट? इसकी और भी एग्जांपल्स हो सकती हैं, but the basic principle remains the same. This is electroplating of a metal ring with gold, and this is purification of copper. These two are industrial applications of electrolysis, ठीक है? And they both follow the same principle, and they both happen as a result of reactive electrodes, right? इससे पहले हम जितनी बात कर रहे थे, they were in the case of inert electrodes made up of graphite or platinum, but this is how it is. And as you can see, we are officially done with 4.1. We are done with all the syllabus points. You can just read them, go through them. I don't think there is anything that is remaining. Describe how metals are electroplated. We've done that. State that metal objects are electroplated to improve their appearance and resistance to corrosion. Yes, that is something I wanted you to know. Why do we electroplate objects, right? Right? Why do we electroplate objects? Why do we electroplate? We electroplate, right? We electroplate. You see, हम एक नॉर्मल सी आम सी मेटालिक रिंग को गोल्ड से क्यों इलेक्ट्रोप्लेट करना चाहेंगे? To enhance its appearance, right? We electroplate to enhance the object's appearance, right? हम एक आईफोन को गोल्ड से क्यों इलेक्ट्रोप्लेट करना चाहेंगे? To enhance the appearance of object. And the other reason is and to prevent it from corrosion. To prevent it from corrosion, right? What do I mean by that? Basically, we protect the object from exposure to air or water, right? We see this ring can get exposed to air and water and it can corrode, right? Corrosion can occur. The details of that you don't need to know. We'll talk more about them in the chapter of metals, जहाँ पे हम discuss करेंगे कि how does corrosion actually take place and the steps that we can do to protect objects from corrosion. उसके अंदर we have sacrificial protection and zinc galvanizing. We'll discuss all of that in the chapter of metals. But इधर what you need to know is कि in order for this to be protected from air or water, और अगर air और water इसे ज़्यादा लगेगा this is gonna corrode. In order for it to be protected, हम इस पे gold plating कर देंगे, right? Because gold, you see, this is the ring, और इसके ऊपर we have gold की plating. So gold is gonna protect the inner metallic ring. It's gonna protect this inner metallic ring from corrosion. See, so these are the two reasons why we, electroplate objects. And that is the benefit of reading the syllabus contents. अगर हमने कोई चीज़ मिस कर दी होती तो हम वो कर लेते हैं, right? Electroplating improve their appearance and resistance to corrosion. See, construct half equations for the reaction and anode and then the cathode, or even we learned how to draw full net equations using these half equations as well. अच्छा जी, predict the identity of products at each electrode of the electrolysis of a halide compound in dilute or concentrated aqueous solutions. We did that. We did in its molten state as well. हमने metals and hydrogens are formed at the cathode. That is something that you know. Non-metals other than hydrogen are all formed at the anode, again because those are the anions जो कि anode पे जाएंगे, और anions are always non-metals, ठीक है? Hydrogen is the only exception, by the way. As I told you, hydrogen is part of the reactivity series as a reference. Identify the products formed at the electrodes and describe the observation made during aqueous copper sulfate using inert electrodes, जो कि हमने starting में किया था, right? जिसमें we said कि light blue color is fading and all. And when using copper electrodes, the part we did today using copper electrodes in the case of purification of copper, जिसमें हम कहते हैं कि electrolyte का color change नहीं होता, etc. See, molten lead bromide, concentrated solutions, dilute sulfuric acid. We did all of these examples. The movement of electrons in the external circuit, that is something that's very important. You see, movement of ions happens in the electrolyte, loss and gains of electrons, reduction or oxidation की reference में we did all of that. And we were able to do all of this as well. So we are officially done with 4.1. 4.2 remains. It's a very small concept. It's barely a 10-minute concept. We're going to do that quickly in the next class and hop on to past paper questions, and that is going to solidify a lot of your concepts.